All right, welcome to day 2. Today we're going to talk about other bases besides base 2. We'll still talk about base 2 and base 10 still, but we're going to include like base 3 and maybe even some base 5 in here. And the reason, well, we're also going to look at base blocks as well. So that way we can see the importance of base 10 and the base 10 block manipulatives when you're talking about elementary school math and that sort of thing. So the first thing I want you to do is go over to your week 1 resources, and you should have something in there that looks like this, counting cubes at different bases. And I want you to open that up. You just click on that and you can print this file out, or if you've got a way like you're on a tablet and you can write on that, go ahead and do that. And this says to grab a few handful of cubes. You really don't have to grab cubes. You can really grab anything. A handful of pennies will work. I've used paper clips in my class before. Candy like M&Ms or whatever else you want to use. All we want to do is just grab a random sample and count them. And so cubes you can substitute with whatever you're using there. So I'm going to do the activity with you here, and I've got some pennies here. I'm going to grab them out at a time, just a handful of them, and I'm going to write down the total number of pennies I have right here and the number of groups I can form if I group them in threes and my leftovers, okay? So I'm going to pause the video because I don't want you to sit through this whole thing while I do it. I'm just going to write out random handfuls right here, and then we'll go through and fill out these two columns together. You can do the same if you want. Just take a handful of whatever you're counting there and count the total amount and just write them down in here. We want to do that kind of randomly. You don't need a whole lot. I would say, you know, at most you should be grabbing out at 15 at one time, but you can grab out, 10 at a time or so, something like that. Okay, so here I am. I've got each random handful of whatever I was grabbing pennies out, written out, and I'm going to put these into groups of 3. So it's actually better if you do this one at a time. I just want to kind of do this quickly for you. So you can just grab out 12. How many groups of 3 could you group 12 into? And you could group it into 4 groups of 3. So it would look, if you're doing pennies, you would organize your pennies to look like this. So you'd have 4, what did I say here? 4 groups of 3. My bad. Let's move that around a little bit. How about that? You know what? I was doing 3 groups of 4. We want 4 groups of 3. Mistakes happen, right? 4 groups of 3. There we go. And we have none left over. So when I'm looking at this, I'm going to say 4 groups of 3 with none left over. Now, if we grabbed out 7 pennies, well, 7 pennies would give us 2 groups of 3 with 1 left over. So it would look like this. That would be 7 pennies. So we could form 2 groups of 3 and 1 left over. Coming down my list here, if I grabbed out 10, I could form 3 groups of 3 with 1 left over. If I had 9, I would get 3 groups of 3 with none left over. And now I'm going to reach the next stage where now we're grouping them into 7s. So it's a little bit different. Let's see, if we had 12, I could get 1 7 with 5 left over. So in this case, if we're talking pennies, this is what it would look like. Let's erase these. I would have 7 pennies, 1, 2, 3, 4, 5, 6, 7, and 1 left over like that. Did I say 1 left over? 5 left over. Sorry, I forgot how many I had there. 2. So I'd have 7 pennies and 5 left over. That's the best I could do with that. If I had, let's see, 15, well then I could do 2 groups of 7, and that time with 1 left over. So in this case, I'd have 2 groups of 7. Let's group that and copy and paste it. There's 2 groups of 7, and this time I'm only going to have 1 left over. So this is 7, 14, 15 total pennies there. If I had 17, once again, I could get 2 groups of 7. And this time I would have 3 left over. 13. Still grouping it in 7s here. I'd have 1 7 with 6 left over. And then down here, notice we got groups of 10. I know this isn't quite aligned. It's from where I was copying and pasting it from that worksheet into the Smart file here. But if I drew out 10 pennies, how many groups of 10 could I make? I could make 1 group of 10 with none left over. With 9, I could make no groups of 10 with 9 left over. With 21, I'd get 2 groups of 10 with 1 left over. And with 32, I'd get 3 groups of 10 with 2 left over. So as we look at this, I want you to take a look at how this works. You know, we got the green, red, and purple. I just kind of separate by color just so you can see where the breaks are a little bit easier. But look at these questions down here. What do you notice about the chart? Which groups are the easiest to count and why? And what other observations can be made from this chart? So think about that. And you know, in a classroom setting where we're live talking to each other, I could ask you questions, but I wanted to just give you a few hints here. For one, this is really close to base 3, but it's not base 3. And the reason why is we've got a 4 and a 3 in here. Remember, with base 3, you can only have the numbers 0, 1, and 2. We haven't really talked much about base 3, but with any of those base number systems, like with base 2, you don't actually have the number 2 in there. Base 4, you're not going to actually have the number 4. It's going to be 3, 2, 1, and 0. So you can't have like the number 40 in base 3 or 40 in base 3 because you've got that 4 there. You can have 2, 1, and that does represent 7. We'll talk more about that in a moment. For you, what do you think, as you were doing it, which one was the easiest to do? Well, if we look down to our base 10 right here, notice that this says 1, 0, just like the number 10. This says 0, 9. If you ignore that 0 because it has no value, it's just like the number 9. 21, 2, 1. 32, 3, 2. So unless you were pulling out like 1,000 pennies, which hopefully you weren't counting that many and grouping them, as long as it's less than 100, then you had the number of 10s right here and the number of 1s right here matched up with your number. And so as we explore these things, we start to see the significance of base 10 in our number system. Now, when we talk about base blocks, where you may recognize these, whenever I pull these out in class, people are always like, oh, I remember that from elementary school, or they've taken some, where they've assisted teachers, or I have teachers in class that are very familiar with them. This is our typical start to our base 10 blocks. And as we talk about these, we're going to call this right here a cube. This is a rod. And this right here is a flat. And that's the basic pattern. It gets repeated over and over again. You've got cube, rod, flat. And then what is this then? Oh, that's another cube. Now, how many cubes do we have counted right here? We've got 1. This is a rod is made of 10 cubes. A flat is made of 10 rods, or 10 by 10, in this case 100 cubes. And then this cube, this next cube right here, notice is 10 flats. So if each flat has 100 cubes in it, and you got 10 flats there, it's going to have 1,000 little cubes there. And then the process starts over, right, starting with this cube right here. So if I wanted to make the next rod, it would be 10 of these 1,000 sets of cubes. All right, and it would pile up just like this one. So I could actually do that if I wanted to. I'm not going to go, like you could pile them up like this. 1, 2, 3, 4, and straighten them up and make a rod just like that. We're not going to do that for here in class. Sometimes I try to, although none of my manipulative sets in class really have enough of these 1,000 blocks right here to make a major rod like that. But in general, we can take a number like 3,425 and use that in the class to represent it using base 10 blocks and really help our students understand what it means by the base 10 number system. Now, if you don't have manipulatives, some classrooms have manipulatives and you can use them. Maybe you've got them on your own and you can use them as you do these assignments. I've got a couple of resources out there for you. So if you go to our week 1 resources, you can look at base block cutouts. And I've set this up so that you can print these out, cut them up, and you can use these as like paper manipulatives. So if you don't have the little more costly plastic models, you can use that. And then in a little bit, we're going to talk about base 2 and base 3 blocks, and I can't find those anywhere to purchase online, so I've got them there. I kind of made a crude copy there. You know, I had to cut them out of these shapes because I couldn't find them anywhere picture-wise for you to print out and use. Now, another thing you can do is if you Google NVLM, actually NLVM, that is the National Library of Virtual Manipulatives. There's some manipulatives there you can use. Now, the problem I have when I go here and I try to click on something, like we'll do base blocks, my Chrome doesn't really have Java, and so that messes me up. So what I like to do is just take that address up top and copy it, open up Internet Explorer. And so I'm going to just type in over here on the bottom left, Internet Explorer. And then I'm going to paste that into Internet Explorer here. You can't see the bar, it's outside of the recording zone, but you get this right here. And it says a run Java. Yeah, run it anyway, and it needs to be updated. And so now here I've got some manipulatives I can use where I can just add these blocks in here if I want to as I go along, and it tells me the number over here on the right. The nice thing about this is, let's clear it out, you can also change the base. It's the only online manipulative I found where you can change the base. So in a moment we're going to look at base 2 blocks. So down here I changed it to base 2, and I can add base 2 blocks in there. So that's what it's going to look like with base 2 blocks. And so we'll check that out in a moment, but that's a great resource, and I'll try to post a link to that there for you later on as well. So let's go back to our page here. Let's look at how we can represent 3,425 if you're not familiar with base 10 blocks and how to use them. Let me show you what we mean by that. So I've got 5 ones. So I'm going to take the little cubes there and throw 5 of them in there. So there's 5 there. I've got 2 10s. So each one of these rods have 10 in it. So there's 2 10s. And I've got 4 100s. So each of these flats have 100 in it. So I'm going to put 4 of those in here. I'm going to scroll down a little bit so we can have a little more room. So there's 4 flats. And then I've got 3 1000s. So each one of these blocks is 1,000. So you got 3 1000s, 4 100s, 2 10s, and 5 1s. Now, if you're going to be an elementary school teacher, I'm sure you're going to take classes on methods on how to teach this type of math where you're showing place values. Today, I want you to kind of just appreciate these manipulatives as we look at other bases that you may or may not be teaching in the future. But as you go through and struggle to learn other base systems, you can see how these manipulatives there help you, and then you realize the importance, maybe if you ever do teach this stuff, of how base 10 blocks help the young learner learn these things. So that's base 10 blocks right here. What would base 2 blocks look like? Well, base 2 blocks start off with the same thing, a cube. So that's how all of these work right here. You got a cube you start off with. Now with base 10, a rod was 10 high, and base 2, a rod is going to be just 2 high. And once again, I actually, when I made these, I couldn't find these images anywhere online. I just went through and cut these out. So they're kind of a little bit of a rough cut, but they work for what we need. A flat in base 10 was a 10 by 10. A flat in base 2 is going to be a 2 by 2, like that. And so that's the first part of our cycle here. So the cube, in base 10, it's a 10 by 10 by 10. Let's see, 10 by 10 by 10, like that. And base 2 is going to be a 2 by 2 by 2. So it's going to look like that. So I know this one looks really rough, but that's what our base 2 block system is going to look like. And then once again, if we started over and start making the rod, it would be a two, you'd stack 2 of these high and go forth from there. So in base 2, if I'm wanting to represent this number in base 2, I would have 1 cube, 1 rod, no flats, and then 1 of the larger cube there. So this represents the amount when I'm talking about the number 1011 in base 2. So let's talk about what that is. We said in day 1 we talked about how to convert this into base 10, but now I could look and say, hey, how many blocks are in a 2 by 2 by 2 cube here? Well, there's 4 right here and 4 in the back, so there are 8 cubes there. There are no cubes right here. I'm going to add these number of cubes total up in this system. There are 2 right here, and then there's 1 right here. So 8 plus 2 plus 1 is 11. So this is the amount 11 in base 10, or the number 11 in base 10, 1011. And so once again, if we were converting this like we did last time, we would say this is like 2 to the 0, this is 2 to the first, this is 2 squared, this is 2 cubed. Notice 2 cubed is 8, that's where we get this 8 from. 2 squared is 4, there are 4 blocks there. 2 to the first is 2, that's where we get this. And 2 to the 0 is 1. So hopefully that kind of reinforces things we talked about on day 1. And you can see how we could use base 2 to further learn about, or base 2 blocks to further learn about base 2. And once again, this is the number 1111 that we just quickly threw out earlier. And so this shows that we got 8 here, 4 here, that's 12, plus 2 is 14, that's 15. This is the number 15 in base 2. So this might be helpful if you're just wanting a quick way to do these blocks, but I think it's helpful as far as, doing blocks. You can also make it give you problems, like show a problem on this thing, and it says use the blocks to show 1, and you can click on that, and there's 1 and base 2 and so forth. Now, as we get into base 3, let's start a new discussion here for base 3. Remember that for base 10, we did things like we said 10 to the 0, 10 to the first, 10 squared, 10 cubed, and so forth. And so if we had a number like 3,521, that meant we had 1 1, 2 10s, 5 100s, and 3 1000s, because this is 1,000, 10 cubed. This is 100, this is 10, and this is 1. We did the same thing when we talked about binary. We said if we had 1 0 1 1, then we said 2 to the 0, 2 to the first, 2 squared, 2 cubed. So this is 1, 2, 4, and 8. So that means we had 1 8, 0 4s, 2 1s, 1 1. Adding those up, we got the number 11. We're going to do the same thing when we talk about base 3. We're going to say we've got 3 to the 0, 3 to the first, 3 squared, 3 cubed, and so forth. That's a cube. And so this is like having 1, 3, 9, 27. So if I've got 2, 1, 0, 2 in base 3, if that's my number in base 3, it means I have 2 1s, 0 3s, 1 9, and 2 27s. So you could say this is like 2 times 1 plus 0 times 3 plus 1 times 9 plus 2 times 27. So if you're saying how come we can have a 2 here, remember with base 3 we have the digits 0, 1, and 2. With base 2 we only have 0 and 1, and with base 10 we have 0 through 9. So as we talk about these, it's always the same number of digits. Like base 3 has 3 digits, base 10 has 10 digits, base 2 has 2 digits. It's just you don't really, you might want to include that 3, but it's always one less than that digit there. So looking at base 3 here, let's use our base blocks. Maybe that was a little too fast for you. So let's use our base blocks to try to figure out how to convert a number like 2021 in base 3 to base 10. So notice I've got base 3 blocks here. If we were looking at my original list right here, here's our base 3 blocks. The first one is just going to be our basic cube. The rod is going to be 3 high. The flat will be a 3 by 3. And then our next cube is going to be a 3 by 3 by 3, kind of like a Rubik's Cube. All right, once again, that's a rough cutout because I was doing it by hand. So if you think about the amount of little blocks in each one, this one has 1 block, this one has 3, this one has a 3 by 3, so it's 9 blocks. This is a 3 by 3 by 3, so it's 27 blocks. Once again, remember what that means. This is, in base 3, we got 3 to the 0, 3 to the first, 3 squared, 3 cubed. So you can see how we're following that same pattern. The next one would be 3 to the 4th. Because think about it, a rod is going to be 3 of these stacked up high. So, with that being the case, let's look back at this. Here's our base 3 blocks drawn out. And so I've got one of the cubes. I've got 2 flats. I've got, not 2 flats, 2 rods. I've got no flats, and then I've got 2 of the next cubes here. And so let's take a look at what this number is. This is going to be just 1 block here. There are 2 times 3, or 6 blocks right there. There are no blocks right here. And then there are 27 plus 27, which is 54 blocks right here. So if I add all the blocks up, I get 61. And so that's my number in base 10. So once again, we can see that this means, this place digit in 3s is 3 to the 0, 3 to the first, 3 squared, and 3 cubed. What's 3 cubed? It is 27. How many 27 of these do I have? I got 2 of them. So it's 2 times 27, which is 54. What's 3 squared? It's 9. But how many of those 9s do I have? I have none. So it's 0 times 9. What's 3 to the first? It's 3. How many of those 3s do I have? I've got 2. So 3 times 2. See? 2 3s there. What's 3 to the 0? It is 1. So I got 1 of those, and 1 times 1, it gives me 1. So what's in red multiplies to give you what's in green, and then adding those up give you the total number of these little cubes all throughout here. Now, a couple other things to note. Let's suppose I had one more rod in here. So if I had one more rod in here, how many of these rods would I have? I'd have 3 of them. And this number would have to change to a 3. But the problem is, in base 3, the only digits that are in base 3 are 0, 1, and 2, not a 3. So you can't write the number 3 right here in base 3. It's not part of the base 3 number system. Why not? Well, if you look at this, it should make sense. What happens when I push all of these rods together? I get one of these flats. I know it's a different color, but it still becomes a flat. So all of these get bumped into the next zone here. It becomes a flat, and so this just becomes 0, and this becomes a 1. And then our numbers all down here change because we added 3 to it, should become like 64. But I want to show you like why we have those flats and why we can't have a 3 in here. Once again, if I add 2 of these little red blocks over here, let's go. Then what happens? Well, I can't have a 3 right here because this adds up and becomes a rod. And then all 3 of these would bump over here as they became a rod. This would become 0 of these 1s, and this would become 1 rod. So if you had these and you could print them out, you know, and work these, and maybe I'll save this file for you and let you, if you've got smart software, maybe you can play with it in here as well. I've got these set to infinitely clone, so you can just keep pulling out as many as you want as you drag and drop them. But if not, just cut them out. I gave you that resource, and you can play around with them and kind of see how base 3 and such works. Once again, that other resource I had on this site was nice because you can change the base. Let's see, you can do base 3, you can do base 4 down here. And so if you did base 4, boom, there's what base 4, that big cube looks like on base 4. It's a 4 by 4 by 4. There's your flat, there's your rod, and then there's your singular one. If you change it to base 5, you'll have a 5 by 5 by 5. So I know it's this site's a little bit of a pain now that they're starting to kind of phase out Java. But like I said, it's the only one I've been able to find that allows you to change the base. Whenever you Google like base blocks, it's always base 10 because that's the one we mainly use. If you find something different though, I'd be more than happy if you sent me some type of message so I can share it with others. So I want to go over through a few examples with base 3 with you. Here, and you can use those blocks if you want to, if it helps you out. You know, you got those manipulatives, use them. Or we can do it the algebraic way right here, just calculating these things out. So here I have the number 2101 in base 3, and your directions are to convert this to base 10. So pause the video and try that out. See what you get for your answer. All right, so if you've done that, I want you should have done something like 3 to the 0, 3 to the first. We've got 4 columns here, 3 squared and 3 cubed. And we know that 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9, 3 cubed is 27. And I've got 2 of the 27s, 1 of the 9s, 0 of the 3s, and 1 of the 1s. So I'm saying 27 times 2, 9 times 1, 3 times 0, and 1 times 1. And so this becomes 2 times 27, 54, plus 9, plus 0, plus 1. Add all those up and you get 64. So this is the same thing as 64 in base 10. And I'm going to give you some of these for homework so you can try them out and ask me questions if you have questions on those. But what if we had a number, let's do another number like 25, and this is base 10, and I want to convert it to base 3. Well, you did some of these for homework for binary, so let's see if we can do this with base 3. The same method still applies here. We can say, once again, 3 to the 0, 3 to the first, 3 squared, 3 cubed. Pause the video if you want to try it out before you see me do the answer. 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9, 3 cubed is 27. Now 27 is larger than 25. So I'm not going to do that subtraction method from 25 with 27. I'm going to start with 9. So I subtract 9 from it, and I get 16. I can still subtract 9 from it. So I'm going to subtract 9 again, and I get 7. Now if I subtract 9, then my number is going to be negative, and I don't want to deal with that right now. It really doesn't work for this method to talk about negative numbers. How many 9s did I subtract? Well, I subtracted 2 of them. And then I'm going to move on to the 3 here. So I'm going to subtract 3 from this, and I get a 4. Subtract 3 again, and I get 1. I can't subtract any more 3s, or I'm going to get a negative number. So how many 3s did I subtract? I subtracted 2. And then lastly, I'm going to subtract that 1 from this. And when I subtract 1, I get 0. So I subtracted 1 from it. And I get none left over. So this is my number in base 3. So 25 base 10 converts to 221 in base 3. And if we're looking at our manipulatives, 221, let's try drawing that out. So 221, let's see, that would be 2 of these, 2 of these, and 1 of these. So this is 2, 2, 1 in base 3. How many blocks do I have here? Well, I got 9 plus 9, which is 18, plus 6. 18 plus 6 is what? 24, and then plus 1 right there gives me 25. So let's do another one, and this time I'm going to, hopefully you're starting to catch on to these. If not, you can ask me for some more examples, or we can meet in my office hours and we can go through some. Let's try doing a base 5. Now, I want to ask you a couple of questions you might see on a quiz so that you're ready for them. First off, how many digits do you think there are in base 5? And list them out. So in base 5, oh, these are horrible vertical lines I'm drawing here, huh? So I'm not teaching art. We've got 5 to the 0, 5 to the first, 5 squared, 5 cubed, and so forth. And so if we're looking at this, this represents 1. This is our 5s, this is our 25s, and this is our 125s. That's 5 cubed is 125. So if I've got numbers in here, I can have something like 4, 3, 2, and 1 here. That's a number in base 5 that's possible here. And it represents 4 1s, 3 5s, 2 25s, and 1 125. So that's one way we can convert that. What I can't have, though, is the number 5. Because if I got 5 1s, then I can move that over here and make it just one group of 5. You know, it's like I got 4 blocks right here already. And then 3 rods of 5. So if I added 1 right here, I can make it a rod and move it over here. So you don't have the number 5 in it. So that, going back to that question, how many digits are there? There are 5. And to list them, remember 0 counts as a digit. So you have 0, 1, 2, 3, and 4. That's what I could put into this column for, or any of these columns for base 5. So let's try a problem out. Let's do 3, 2, 0, and 1. Let's say that's base 5. Convert it to base 10. So pause the video. If you didn't pause it, try it out. To convert it to base 10, we'd say, okay, we've got 5 to the 0, 5 to the first, 5 squared, 5 cubed, working like that. We've got 125, 25, 5, and 1. You've got 3 125s, 2 25s, 0 5s, and 1 1. So multiplying these, this is 375, this is 50, this is 0, and this is 1. That's just multiplying these numbers here. And then we're going to add them up. So 375 plus 50 is 425, plus 1 is 426. That's base 10. So that's going from base 5 to base 10. Let's try going the other way. Let's suppose we have the number 37 in base 10. And we want to convert it to base 5. 5 to the 0, 5 to the first, 5 squared, 5 cubed. That's 1, 5, 25, and 125. I'm going to use the subtraction method. Once again, 125 is too large, so I know I have to stop there, because if I subtract 125 from 37, I'm going to get a number bigger than 37. So I'm going to start with 25 and subtract. I get the number 12. So I subtracted 125, can't subtract any more 25s from it. I can subtract 5 twice from it. Subtract 5, I get 7. Subtract 5 again, I get 2. So I subtracted 5 twice, so I got a 2 right there. And then I can subtract 1 2 more times from it before I get to 0 left over. So I got a 2 there. So 37 base 10 is the same thing as 122 base 5. Okay. So I want you to try some of these out. If you have any questions, let me know. I'm more than happy to help. And I'll post that homework for you so you can go ahead and get started on it. Thanks for watching, and hope you're having a good day.